In this chapter, we're going to be studying statistics. In this lesson, we're going to be talking about data.
Okay, hi everybody. So we're talking about data, okay, or data, however you want to say it. So to start off with, we're going to just go through some definitions before we take a look at some examples, just to give you a sense of what it is that we're trying to describe here. So our definitions are going to look like this. First of all, we're going to take a look at population. So when we talk about a population, that is the complete collection of everything that we're doing, looking at in the study. Okay, everything. So our population, for example, could be the classroom. We could be trying to do statistics about the people in the classroom. It could be all of Canada. Okay, it could be just be the school that we are in. Whatever the group is that you're trying to study, there's your population. Sample. A sample is a portion picked out of the population by various methods to represent and make inferences about the population. Okay, so it took a look at in previous lessons about some issues that pop up when you're trying to do some sampling. You want to try to get rid of as much bias as you can, unless of course you are trying to sway your statistics one way or the other. But you want it to be an unbiased sample, and that can be difficult to do. Okay, that can be really difficult to do. It can make a plan to create a sample that isn't biased there. But anyway, that is a big issue here. Now that's really not what we're going to focus on right now. We talked about that in previous lessons. Our main focus now is going to be on the calculations that go along with statistical analysis. Now, before we get into that though, we've got discrete data and continuous data. And we've talked about this in previous classes here, but discrete data, we're typically looking at, like, it consists of exact data points here. It's countable, okay, is usually the way we might describe that. That's not a perfect definition, because there are sometimes, well, no, I guess it does work here. I'm trying to think. There's a couple of exceptions to that rule, not the countable rule, but kind of the way people interpret it. I would say, like, you would exclude fractions here, but sometimes you can, as long as, like, there's a limit to how small your fractions are going to get. And what I mean by that is with money. Money tends to cause a lot of confusion here. Normally, we approach money as if it's discrete, though, where you can't break it down further than the hundredth of a dollar. Okay, we don't talk about it less than a cent, typically. You know, there's probably situations where you can, but in our regular using of money, we don't work it like that. But because of the fraction, the decimal that shows up there, sometimes people will treat that as if it's continuous, and I think that's for the uses that we have. And for anywhere it shows up in these problems here, it's going to be discrete. But better examples would be the number of females in a classroom, IQ scores, the number of cars in a parking lot. These are things that are counted, okay? And they come in whole units. Continuous data, on the other hand, can take on basically any value you can imagine. You should be able to specify to any degree of accuracy. Now, there's typically a limit practically to what we can do with that, but you know, kind of in our theory, the way we understand these things, there really isn't. So, for example, the heights of students in a classroom here, and I think people get that you know, from the time that you are born to the height you are now, you grow through every possible height, every value imaginable. Anyway, so continuous data versus discrete data, and I know we've talked about that before. So, big note here, it's important to realize that it is not the data itself, but the nature of what is being measured that makes the data discrete or continuous. So, for example, the heights of people in a group may be measured to the nearest centimeter, so that the data is the set of whole numbers. Thus, they appear to represent discrete data. However, the heights of people, nevertheless, are approximations. Comes from a continuous number scale. Okay, and yeah, that's just because of kind of our limitations with the way we are forced to work with data here. And with continuous data, we will often break it apart into chunks and just look for data values to show up within certain ranges of data. And you will see examples of that later on. It'll jump right out at you when you cover it here. So now we're going to start with, in our analysis here, now that we've got a couple definitions, now we're going to go to measures of central tendency. Okay, we are looking for the middle of the data, And that is sometimes a little bit up in the air as to how that works here, what we should be doing. Okay, what we use here. So the mean is a really, really common one. And as students, you're all familiar with the mean, where we add up, for example, your marks and divide by the number of marks. So that's we call that your average. But we're using that word kind of loosely here. When we talk about measures of central tendencies here, basically all of these are averages. Okay, the mean, median, and mode here, these are all forms of the average here. It's just that we most often use mean when we call it an average. Now, we are going to use the mu to represent the mean of a population, and then we're going to use the x with the bar over top to represent the mean of a sample. Okay, the median. The median is determined by sorting the data in numerical order. Now, you've got to do that first. If you don't do that first, then your odds are really good that you're not finding the median properly. And then we find the middle value. Now, that's easy if you've got an odd number of data values. It's just going to be the n plus 1 divided by 2 term. So, for example, if n is 15, okay, then the median, you add 1 to 15 to get 16 divided by 2, it's going to be the 8th term. Once you've got them in order here, it's going to be 8th term here. But if you've got an even number of data values, then the median is the average of the two middle terms, or the mean of the two middle values. So you take the two middle ones, add them together, divide by 2. Which means, by the way, that for both the mean and the median, okay, this measure, or I should say these measures, are not necessarily data values. Okay? So what I mean by that is the mean that you find for a set of data might not actually be one of the data values. Now think of it like this. What do they say? The average Canadian family is 1.8 kids. Okay, well, where's that family that has the 1.8 kids? Like, who's that 0.8 child? Okay, it doesn't work like that. It doesn't necessarily have to mean be one of the data values that you're working with. The mode is the data value which has the highest frequency. Okay, it shows up the most often here. Now, it is possible to have more than one mode. Okay, well, there should have been a space there. More than one mode. And we typically would describe that as being either bimodal or trimodal. Now, if you've got more than 3 modes, though, I mean, I've got the etc. here, but I mean, really, if you've got more than 3 modes, then maybe there isn't one data value that shows up the most often. So really, trimodal would be about as far up as we would go on that one. Now, each of these has its strengths. Each of these has its weaknesses. The mean, okay, the mean is, okay, sensitive to outliers. And I know I'm making a bit of a mess here with the notes here, but it's sensitive to outliers. And you've probably seen this before, where if you're calculating the mean, like if you've got like you do a bunch of exams here and you did really well on all of them, but you have one exam that went really badly, that exam mark pulls all the rest, well, pulls your average down, okay? Because the mean is sensitive to outliers. But on the other hand, it considers all the data. Okay. Whereas the median, okay, the median is not sensitive to outliers. Okay, this is not sensitive to outliers. But having said that, this doesn't consider all the values. Now, so there's a bit of a kind of a back and forth between these two here. For example, if you're a sports team and you know you're kind of mediocre, but then all of a sudden you've got one game that was just outstanding. If you're trying to figure out your average score per game, well, maybe you do want to use the mean because it's going to show better. Okay, it's going to pull that average up. Maybe I do want to consider all of those data values. Sometimes you don't. My mother-in-law lives on a street where it's just bungalow, and somebody at the end of the street tore down the bungalow and put up a very, very large house. Now, if you were to ask about the average house price along that street, well, that one house pulls everything up kind of unreasonably above most of the cost of most of those houses there. So in that case, maybe you would use the median because it's really just the one house that's causing that average to move up here. The mode has got its place in another context here. Okay, you're looking for the one that shows up the most often. Okay, so it is still sort of a measure of central tendency, but not in the same way that the mean and the median are. Okay, and we'll talk about the mode a little bit as we go through here, but we're going to be more interested, actually, quite honestly, we're going to be more interested in the mean as we progress forward through this than we are with these two right here. Anyway, that aside here, let's take a look at some examples. Okay, so for this first example here, we're being asked to find the mean, median, and mode of the following data set. Okay, well the mean, in this case we're going to use the mu symbol here because we're going to take the average of the whole thing here. It's really just going to be the sum, okay, of all of those terms plus 10 plus 7. And I'm going to add that 0 in there. Don't get thrown off by that 0. It's still there, okay, that's still a value that I need to consider here. Then I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to divide by 12. Okay, and when I do that, I'm going to get to the nearest hundredth. I'm going to get 5.17. And that's going to be approximately, you got to round that. Okay, 5.17 is going to be the mean. So now what that suggests is that if you take kind of the bulk of the values here, like you add those values all up, you create this pile of numbers here and split it into 2. That's going to be centered here at 5.17. Now compare that to the median. Before I can get the median, what I got to do here is I got to order that data. Well, I've got a 0, I've got a 1 and a 1, so I'm going to knock those out there. A 1 and a 1. The next value you get is a 3, a 4, we got a 5, and then it looks like I got 3 7s, an 8, you'll get rid of the 7s and the 8, the 9 and the 10. I think that's everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12. Okay, now with 12 values here, I know that the median is going to be the average of the middle 2. So it's going to be 1, 2, 3, 4, 5, 6. And then the 7 here. So the 6th and the 7th terms here are going to be the middle. So 5 plus 7 divided by 2, my median is going to be 6. Okay? And notice that that's not even part of the data. It's not one of the data values itself here. Okay? So the median and the mean don't have to be. The way this one works, doesn't matter what the values are. With the mean, it does matter what the values are. Okay? The mean is the center of the values represented. So you add up all of this stuff here, there's an equal amount on one side of the mean as there are on the other side here. The median is the center of the number of data values. The median doesn't care what the data values are, just if I line them up in order, where's the middle? Now my mode is something different than both of those. My mode is simply the number which shows up the most often. And once you've got it written out in order, that's easy to see. It's going to be the 7. Okay, hi everybody. Now we're going to take a quick look at measures of dispersion. And what this is it's the measure of the spread. Okay, the spread of the data. Okay, and because that's important. If you've got, for example, just to give you an idea here, let's say you've got 2 different classes. You've got class 1 and class 2 here, and here's your marks on an exam, and class 1 does something like this, down like this, and class 2 does something like this, where it has this sharp spike there and goes down like this. And let's say that this is the average of the class, and this is the average of the class. And let's say that both classes average, I don't know, I'm just throw out a number down here at 75%. So the mean is the same for the 2 classes here. They're both 75%. Well, which class did better? Well, the answer is going to be 2. And the reason 2 did better is because look at this. a larger portion of the population really is tucked in really tight to that 75% average. Whereas over here, the data is much more spread out. You've got some people that did quite poorly. You do have some people that did quite well, but there's a lot more spread in this. There's a lot more variation here. There's a lot less variation. There's a lot more consistency here. And that's kind of what we're looking at. Now, what I'm just explaining here is really an example of something called standard deviation, which we're going to talk about in just a few seconds here. Before we get to that, the first measure of dispersion we want to talk about here is the range. And the range is simply the difference between the largest and the smallest data values. That's it. Just the difference between the largest and the smallest. So let's take a quick look at an example and then we'll move on. Okay, so here's the example of our range that I was just mentioning here. So here's our data set here, 1, 3, 4, 9, 1, 5, 7, 7. So it's the same data value that we did before here. Our lowest value, okay, is 0. Our largest value, and I gotta look back, it looks like 10. So our range is gonna be 10 minus 0 or 10. Okay. Now that gives us a little bit of an idea of the spread of the data. Now there is a slight problem with this though as a measure of dispersion though. Like what if we have an outlier in the data? Okay, or a couple there. So in other words, what if the data wasn't like this? What if the data was 0, and then it was something like 8, 9, 8, 9, 9, 9, 8, 8, 9, 9, 10, but everything else was really, really, really close to the maximum value there? Well, then our range would still have been 10. It would have looked like there was still a lot of spread to the data, even though really it was just that exceptional data value here. So the range, although it gives a bit of a sense of the spread of the data, is not the best tool to use for talking about the measure of dispersion, but it is a good starting point. Now let's take a quick look at the standard deviation. Okay, so standard deviation. The standard deviation is a measure that describes the variation or spread between the data values and the mean of the data. Okay, we use the little Greek letter sigma to represent the standard deviation for populations. Now, to give you an idea of what's going on here, let's say in my class, I went up and I wrote the average mark on the board for an exam. Now, I'd never do this, but let's just say I did, just to give you an idea of what the standard deviation is. If I then went from student to student and said, okay, how far away from the mean were you? And now, they don't have to tell me whether they're above the mean or below the mean. Okay, I don't care about that. I don't care whether you were, let's say the mean was 75, and if I ask how far away from you the mean, and they say 5, well, then I don't know whether they were at 70% or 80%. So let's just say that's all I ask. How far away were you from the mean? And everybody gives their answer. If we added those all up and then divided by the number of students, okay, that would basically be your standard deviation. So it's the average separation from the mean, so it's like the mean separation from the mean, but it's confusing to say it like that. But really that's what I'm asking for there, okay? And I'm going to show you how you can use your calculator to get that in just a minute here, and what that, we're going to look into what this implies about a data set here. But the smaller the value for the standard deviation, the tighter to the mean the data is, okay? So for example, if I was to draw two different little curves here, I've got something like this and then something like this. This has got a large standard deviation, whereas this has got a small standard deviation, okay? The more spread out, the lower the peak is, the larger the standard deviation. The smaller the standard deviation, the closer it is to the mean value here. Now, another version here, way of talking about this is called variance. And the variance measures the average of the squared deviations of each data value from the mean. And it's represented as the standard deviation squared. Okay, now this might look like it's an unnecessary next step to go here, really just to square the standard deviation. But what you're going to find is if you go to university and you study statistics, okay, you're actually going to go back. If you think back to like one of the earlier topics that you would have covered in the IB material, you'll remember expected value. A lot of these ideas that we're looking at right now, variance and standard deviation and whatnot, are derived from the expected value calculation. And actually, when you do it that way, what happens here is you derive variance prior to getting the standard deviation, and then you end up taking the square root of variance to get the standard deviation of the data. So that's why this is a significant unit of measurement there, but not typically the one that we're going to spend most of our time on. We're going to talk mostly about the standard deviation, but we do want you to understand what the variance is, which is really just the standard deviation squared. Okay, so now, quick note here. It's going to be assumed that you're going to use your graphing calculator to determine these statistical calculations here. So what we've got here is just a quick outline as to how to do this. What I'm going to do though is I'm going to walk you through this when I take a look at an example, because you can read through all of this if you want. In fact, I'll maybe even, whoops, wrong direction. I'll just give this to you right here if you don't have the workbook with you right now. You can take a quick look at this, and this will kind of walk you through how to do that. But like I said, that's easier to follow if I just show it to you using a calculator. So have a look, and away we go. Okay, so our first question here says, find the standard deviation and variance of the following data set. Okay, now I'm going to go through it. I'm actually going to take the opportunity here to talk a little bit about how the calculator works and a little bit more than just figuring that out there. First of all, we have to enter data in. So to enter the data in, I'm going to press the stat button right here. And as soon as I do that, it opens up this menu here. And what I'm going to do here is I want to edit, okay, the information that's in there. Now, I've got these lists that I can use to put data in. And I've already got my list one filled here. I would like to get rid of that data. Now I can go through and delete, okay, just like clear these data values one at a time here, or sorry, I should say delete them one at a time, but that's going to take a while. I don't know exactly how much data I've put in there. So is there a faster way to do this? Well, yeah, but you got to be careful. So now watch this. It would be very tempting to want to move up to the name here and then press delete. Now, I don't know if you could see what just happened there. My list started at list 1. Now it starts at list 2. And if I go to the left, all that does is bump me up to list 6. I've actually lost list 1. The calculator didn't even give me a second to say, is that what you really want to do? It just got rid of it. To get that back, what we're going to do here is press second delete, because right above that is this insert feature. And what that does is it opens up a list just to the left of the one that we were just on. And it's asking me to name it. Well, I'm going to call it list 1. Notice that right above in blue, okay, right above my button 1, I've got L1. So second, 1, and the calculator is going to call it list 1. And when I press enter, oh, it puts list 1 back here. But notice that it brought back all of those values. So it didn't actually delete that list, it just stopped showing it. To clear that list, what I'm going to do here is make sure I'm on list 1 highlighted. I'm going to press clear. And now the calculator pauses for a moment. All the data that was in there is now gone. And the calculator is waiting for me to press enter because it's waiting for me to confirm, is that actually what you wanted to do? So I'll press enter and all the data is gone. And so now what I'll do, whoops, I'll go through and enter all of this data into my list 1 here. 1, enter 3, enter 4, enter 9, enter 1, enter 5, enter 7, enter 10, enter 7, enter, and then 0, enter. And now I'm on the 13th spot right there, which is good because that confirms for me that I actually put in 12 data items. Okay, so now I'm going to press second and quit to get out of there. I want to figure out what the standard deviation is. So I'm going to go back into my stat, but this time I'm going to go over to the calculation menu. And what we just did here, we're doing a one variable statistic. Okay, there was just one set of data in here, okay? So I'm going to press enter on that. And the calculator is now asking me, was that list one? And yes, I'm going to press enter on that. I'm not going to put in a frequency list. Okay, the frequency list is what you put into the calculator when you're kind of taking a shortcut. When you've got a lot of data and you're not going to enter in, like let's say that the number 1 shows up 50 times. Well, we're not going to expect you to go 1, enter, 1, enter, 1, enter, all the way down. We would expect you to put in a little chart and take a bit of a shortcut there. But this is not one of those situations here. So I'm just going to press enter to go past that, press enter for calculate. And now what the calculator has done here is it has given me the mean. The little X bar there is the mean. So 5.17. So that actually should be comforting because that's what we calculated as the mean a little while ago. This means the sum, that little symbol right there, that large sigma there, is the sum of all the x values is 62. The sum of them squared is 444. Don't really need that. This S here is a sample standard deviation, but this right here is the one that we're looking for. Sigma X here is our standard deviation. Okay, that's the number that I want. So our standard deviation here is going to be 3.2. Okay, 3.2. Now, other things that this calculator will give you right now for this data set is it'll tell you how many were there. Okay, it'll tell you what the minimum value was, and then it breaks it up into what we call quartiles. It also gives you the median. So we know that the middle value here is 6, and that again, I feel good about that because that's what we calculated a little while ago here. The Q1 and the Q3, basically what we're saying here is that this is the median of the first half. Q3 is the median of the second half. So it just breaks it up into quarters here. And then this is the largest value here. But for right now, what I'm interested in is this sigma x here. There are 2 different standard deviations given here. If this had been a sample population, a sample of the population, we would have used this one. But for our calculations here and for the rest of what we're doing in this particular course, we're going to assume that we're working with a population. Okay. Now, to go to my variance from that, what I want to do here is I want to square that. Okay. Now, to square that, what I could do is try to write out that whole decimal that I had on there. But there's a better way here. If you press vars on your calculator, it's that button right here, you get this list right here. Now, this is where the calculator stores its variables here. So if you go down here to number 5, this is where it stores its statistical variables. Press enter, and then notice it's got my sigma x right there. Now, if I tell it to square that, there's the square. That's the variance here, okay? So our variance, or our sigma squared, is going to be, in this case, 10.3. Okay? And that makes sense. I mean, we know that 3 squared is going to be 9. This is a little bit bigger than 9, so the square is going to be a little bit bigger than, sorry, the number here is a little bit bigger than the square root. So the square is going to be a little bit bigger than 9. Okay, and there you go. Okay, everybody, let's take a look at this next question here. It says, the table shows the number of errors in randomly chosen pages of a telephone directory. Okay, so there were, it looks like 67 pages where there were no errors, 35 pages where there's 1 error, and so on. You can kind of read that out and follow along here. Enter the number of errors in list 1 and the corresponding frequencies in list 2. Then we're going to calculate the mean, median, mode, range, standard deviation. Okay, we got a lot going on there. Okay, so here we go. So first of all, I'm going to go press statistics. We're going to go into edit. And data I have in here was from a previous question. So to get rid of it, I'm going to go up to the title, press clear, and then enter. And that cleans up my data. And so now what I'm going to do is enter the number of errors in list 1, so 0, 1, 2, 3, 4, 5, 6, arrow over, and now I'm going to enter in the number of times those occurred. So this is now where we're entering in a frequency chart. And so we use list 1 and list 2 in here. So that'll be 67, 35, 17, 8, 11, 2, and 1. So yeah, so I don't want you typing in a 0 67 times down list 1. We're just going to let the calculator understand it by writing out the number of times that occurs. Now, once that's in there, I'm going to quit. Then I want to do the calculation, so I'm going to press Stat. I'm going to move over to the calculation menu. Now, this is still a one variable statistic. Okay, we are only talking about the number of errors. I'm using two lists here, but not because there's another variable that I'm looking for correlation with. It was just a shortcut way for me to put in a lot of data. This is still just a one variable statistic. My list is in list 1, but now I do have a frequency list, and to get L2, it's going to be second, number 2. Go down to calculate, and there we go. And so now we're going to pull out the information that we're looking for here. So we want the mean. Okay, well, the mean, okay, the calculator is using that symbol right there, but that is going to be the mean. And so let's go to the nearest, well, okay, we'll go to the nearest tenth, even though, I mean, our data values here are, that doesn't really make a whole lot of sense, but we'll go to the nearest tenth anyway. So that was going to be 1.1. So approximately 1.1. What is the median? Well, as I mentioned to you before, if we slide down, the calculator actually does figure that out here, and the median is 1. Okay, which that's kind of interesting, because what that means is, okay, if you were to line up all of this, like if you were to write out all of the zeros, all of the ones, all of the the twos and so on, and just find the middle number out of all that, it's going to be the 1. Okay, so there's the same number of let's say zeros and ones to the left of it as there are going to be all of these other numbers to the right. Just gives you an idea of the sense of the spread of the data. The mode. Okay, well, the mode, I don't even have to go to my calculator to figure this out, because the mode is simply the one that's got the highest frequency. I mean, that's by definition what the mode is. So that's got to be the 0. It shows up 67 times. Now our range, okay, is going to be the largest number of errors minus the smallest number of errors. So it's going to be 6 minus 0, or 6. That's the spread in the data. Okay, and our standard deviation, okay, well, our standard deviation, go up here, is going to be right here, 1.4. Okay, approximately 1.4. Okay, so that means when you look at how many errors all of the pages have, okay, and compare it to the average, which was 1.1, on average a page is about 1.4 units away from that. Okay, which isn't too bad. It's pretty small there. Now, is this data discrete or continuous? Well, we're talking about the number of errors on a page. Okay, can you really conceive of a half error? Well, not really. I mean, it's either right or it's wrong. So this is going to be discrete. Okay, and the reason being here is you can't have like a fractional error. I mean, I know when we mark stuff for you, we'll often give you half marks, but that's that's not the same thing. That's just that is a full mistake that we're only weighting at a half mark here. Now, how many pages were surveyed? Well, the number of pages surveyed is going to be the sum of the frequencies here. Okay, 67 pages had none, 35 had 1, and so on and so forth. I could add those all up, but actually the calculator has done that for me. That is the n value right here. So the number of pages here, okay, n is going to equal 141. That's the number of pages. And so there it is. That's how you'd use your calculator to analyze that set of data. Okay, let's take a look at this question right here. A class of 28 students, okay, wrote a test and received an average mark of 78%. Now, two students who were absent on the day of the exam wrote the test at a later date and both received the same mark. If the new class average is 79, what mark did the two students receive on their test? Okay, so what we're doing here is we've got 28 students there, okay, that each got, that when you found the average of that was 28 here. So let's say we've got student 1 plus student 2 plus ... plus student 28. And when we divide it by 28, okay, we're getting 78%. Okay? 78%. So that's what that first little bit of information is saying. Now, we're changing our scenario a little bit. Now we've got student 1 plus student 2 plus ... plus student 28. And now we're adding student 29 and student 30. Each of which are going to have the same mark. And when I divide that by 30, I'm now getting 79. So, I mean, the nice thing is I know those two marks are exactly the same here. So now I'm going to use this information to help me simplify this right here. Because if I multiply up by 28, set S1 plus S2 plus ... plus S28 is going to equal 28 times 78. And I'm just going to go on my calculator over here and do that. And so S1 plus S2 plus ... plus S28 is going to equal 2184. Now what I can do is I'm going to replace all of that with 2184. So this is going to be 2184 plus, now, and it's going to be these two right here. So at this point right here, I'm not even going to differentiate student 29 and student 30. I'm just going to say plus 2 students over 30 is going to equal 79. And now I will multiply up by the 30, so 79 times 30, and I'm just going to do this a little quicker here. I'm going to get 2370. I'm going to subtract the 2184. So I'm going to bring that over. So 2S, 2 student marks, is going to be 186. And now finally I'm going to divide by 2. And each of those students got 93%. Wow, they did really well. Both of them together. That is suspicious. Anyway, that's how you would handle that question like that.